I'm John Morley. I'm currently a geophysics student at Imperial College London. And this quite long title, I will be doing a talk on the increasing demand for minerals and metals for the green energy transition, a wicked problem. So quite a evocative question at the end, I must say. So we'll get straight into it. To begin with, this is just setting the scene for the presentation. So this is a figure from the International Energy Association released from a report last year where it shows some selected minerals and their usage in certain power generation and transport. So as you say here are the industries I'll mainly be focusing on throughout the presentation. And as you can see, it goes from conventional energy sources such as coal and natural gas fossil fuels all the way to renewables and also conventional cars, internal combustion engines compared to electric cars. I just want to highlight, obviously here it only says a select type of minerals and metals. So base metals such as iron aren't included in this, which would obviously contribute a vast quantity. But as you can see here, there is a huge material diversity. And just from the offset, you can see that renewable technologies such as solar panels and wind require vast amounts more metals and minerals per megawatt than conventional power generation methods, and the same for electric cars. The diversity in the metals that's presented here, metals and minerals, even though there's only a select number, the 6 compared to 2 is quite dramatic, showing there's going to be an increase in metal and material diversity and an increase just in general. But setting the scene also for the rest of the presentation, just want to highlight where are the construction materials and aggregates within this. Obviously, huge amounts of cement and concrete are going to be required to build the infrastructure, build the factories to make the cars, the foundations for wind turbines. And hopefully throughout this presentation, I'll try and emphasize that as well as what's more typically people hear about in the media, such as lithium and cobalt, for example. So, as it says in the title, some people, I guess, may be thinking, what is a wicked problem? And as it says here, it's actually a term in policy created by Rittel and Weber in 1973. And the definition here is a problem in policy that is impossible to solve due to the interdependency of factors. So it is an issue where there is no defined solution, no silver bullet to solve what is happening. Typical examples, not within the setting of what I'm talking about now, are examples of such as like growing inequality within wealth in the world and the issues of terrorism globally. So maybe that gives a more understanding of what I mean by this wicked problem. So when talking about the need of metals and minerals for the green energy transition, obviously this relates to the issue of climate change. So to start with setting up this wicked problem, I'm going to give a brief outline of what are the targets. So how is the world trying to combat climate change? To give a setting to what I'm going to talk about later. So, as I'm sure everyone knows about, the COP conferences have been going on for many years now, and the most recent one was in the UK last year in Glasgow, the COP26. The target is to keep global warming within 1.5 degrees, and to do that by reaching net zero in 2050. The most recent things that came out of the recent conference in the UK last year was new policies regarding the phasing out of coal and the limitation of deforestation. But more importantly, these second 2 bullet points where I'll be focusing more was the trying to speed up the transition to electric vehicles and the increase and the encouragement of investment in renewable technologies, as this will definitely lead to an increase in the demand for metals and minerals. So, we're going to be coming back to this figure quite a lot as it grows through the presentation. So I hope you all enjoy seeing it quite a bit. So now we've set up what the problem is. Obviously, everyone knows the issue of climate change and the targets required to meet it. So next up is saying, obviously, to meet these requirements for the green energy transition, we need an increased demand for metals and minerals. So now I'm just going to do a little overview, quite broad overview, of why is there going to be this increase for metals and minerals. So I'll go through a couple of examples, linking back to that figure at the beginning. And obviously there's the electrification of cars. So from this figure and from a Nature article, you can see the number of vehicle sales are predicted to actually plateau in 2035, but the proportion of battery electric vehicles is going to rapidly rise to over two-thirds the number of sales complete by 2040. Now, this is important, as shown here, the amount of all these metals is going to increase and the demand for them is going to grow as well for the use within batteries and just producing the technology within the cars. So the CAGR in that table is the compound annual growth rate. So for all these metals, the amount of metal is going to increase by roughly 10% for most of them each year. And obviously most people, like I said, have heard of lithium and cobalt in the news, but more common metals such as aluminium and copper are going to be required for the wiring and other things within the vehicles. Also, going back to what that figure showed in the introduction, there was the changing of from more fossil fuel energy to now renewable energies. So we're going to focus, there's many types of renewable energy, hydroelectric power and tidal power, for example, but for this I'm just going to focus on photovoltaic cells, solar panels and wind turbines. So this just highlights what I was talking about earlier, the use of rare earth elements, for example, for batteries and magnets, but also the use for more common metals and base metals such as iron to make the steel for the wind turbines that people may not consider, or the aluminium for the blades, and also the copper for wiring. And people may not realise there's this increase in demand of the more common metals, as well as these new rarer metals that are now becoming more in the public consciousness. I just want to highlight that this table from the USGS talks about the metals required for, I think it was solar panels, and you can see that some of the rare elements required here, such as cadmium and gallium, they're normally mined as a byproduct of other more common metals such as zinc and aluminium and copper. Therefore, if this demand increases, the world can't just readily go out and mine more of these metals because they're not mined generally on their own. Therefore, it's quite difficult to meet this increased demand if you can't directly go and target these metals because they're in such low concentrations within the earth. They can't be mined for themselves commonly. So finally, looking at why there's this increase in demand, I want to then talk about the use of aggregates, like I was saying, for construction, which is quite maybe common, forgotten in the headlines. So I just want to highlight here, obviously, aggregates are used to make concrete, such as crushed rock, gravel and sand, and used to make cement, so gypsum as well. This graph from a United Nations report on sand mining from 2019 shows that the demand for sand approximately nearly doubled, under half that, within 15 years. However, as you can see here, there is a sudden decrease around the time of the global financial crisis. Now, obviously, the likelihood is this demand is going to increase even further as these aggregates are required for the concrete and cement required to build all the infrastructure for this green energy technology. So, as it says here, an example, as everyone I'm sure knows, it's about the Three Gorges Dam in China. That required 65 million tonnes of concrete. And obviously, if we have more, maybe not on that large scale, but more hydroelectric dams around the world, this will require vast quantities of aggregates, which will have to be mined from riverbeds or open pits, which have their own environmental issues that maybe, until more recently, haven't been more in the public sphere. Unlike, like I say, metals that are normally seen, such as cobalt and lithium and tantalum, normally talked about. So now I just want to reiterate this point about how maybe how this is seen in the headlines and portrayed, all these issues with the increasing demand for metals and minerals. So it's from The Guardian. You can get very emotive titles looking at the issues of child labour and illegal mining by crime groups in the DRC, especially related to coltan mining. This then follows on with how it then companies such as Tesla and even Apple who use these metals have been drawn into the issue as people see as them using these items fund this criminality in those countries. And obviously it's focused on these metals used for these metals such as cobalt, lithium and tantalum and so on, required for batteries, required for the green energy transition. However, there is starting to become more spoken about the use of aggregates, as it says here by BBC article, like why is the world running out of sand? It's obviously a commodity everyone thinks is available from beaches and so on, and deserts even. However, this has become it's becoming more in the public sphere, especially recently with silicon chip shortages, even though that requires a very rare version of silica, a very pure form, because it relates directly to people and their lives, the use of silicon chips, it's becoming more part of the news now. So now, as I said, we're returning back to the wicked problem. We've now set out how are we going to combat climate change? That's why our metals and minerals demand going to increase. So obviously the easy solution is if we need more metals and minerals, we'll mine more. And if we mine more, we'll have all the metals and minerals required to build this green energy technology and combat climate change. And you'd think that looks quite a simple three-part loop. However, as I've said before, is a wicked problem, there is no just one easy solution. As, if I shift this to the right, we've obviously neglected all the issues regarding the increased mining required. So, adding this in orange here, so what are the subsequent issues? It can't just be this easy. As we all know, mining can have multiple issues. And obviously increased mining can lead to exacerbation of these issues or the creation of new ones. So now I'm going to dive into what these subsequent issues or exacerbated issues may be. So, first of all, we've maybe got the possibility of increased illegal activity. Increases in illegal activity occur as obviously when demand goes up, criminal groups want to take part in the mining process to make more money and make quick money. So here's a picture going back to sand mining in some countries, literally just shoveling it on to trucks. And there's been huge issues in countries like India where they now have so-called sand mafias, where criminal groups run these mining operations, and it hasn't been made official, but there's supposedly been local officials and councillors murdered in order to protect their mining they do in the area. There's also the energy requirements for the green energy transition. So it's here, obviously, like for example, a wind turbine has a lifespan of about 10 to 15 years on average. So some people do question whether the energy required to produce it and the huge amounts of materials is actually worth it for that short lifespan, and obviously the high levels of maintenance required. There's also increases in political tensions. Increased demand will lead to increased trade, which may lead to strains in supply routes between nations. And an example is with Singapore. It's a bit small here, but if you can see the difference in the colours, this is how Singapore has expanded its island via land reclamation projects by importing sand from local countries such as Indonesia and Malaysia and Cambodia, for example. This has led to increased mining in those other countries and led to huge environmental degradation, which has then led to bans in the trade of sand to Singapore and souring of political relationships between those nations. And finally, it's quite obvious, but obviously if mining isn't well regulated or the considerations aren't made before actually the start of a process, there can be the issue of huge environmental degradation. So I guess lots of people, like we've spoken about before in other presentations, we all know what the environmental issues may be, but I just want to highlight, for example, with cement production, the requirements of cement to produce all this infrastructure for the green energy transition. Cement actually emits 8% of the CO2 released in the world. Therefore, having this increased infrastructure will lead to the release of more CO2. So it's kind of a circular problem, which links back to this wicked problem idea. There is no easy solution. So it may seem quite a dire situation coming back to this. We're thinking we're just making things worse. We thought our easy solution of mining more and getting more metals and minerals with green energy technology would be the solution, but it has all these issues. However, I will go over maybe some very broad solutions. And as I said, as it's a wicked problem, there is no definitive solution. However, there is a large variety of ones that can be used to try and combat these subsequent issues. So possible solutions, it could be stronger governance and monitoring. So stronger government policies on mining practices and greater monitoring to try and spot this illegal mining and clamp on it quite quickly. This actually semi-links to research I've done before, where I created a database for the extraction, trade and use of sand and gravel in the UK. And here's quite boring, but it's some of the Excel sheets showing where all the data was conserved. And through the analysis of data and greater monitoring, you may be able to spot issues within supply chains and illegal mining, for example. You can have the option of increased recycling. Obviously, if you recycle more, that will decrease the demand for raw materials extracting from the ground. And this is a report by the Mineral Products Association looking at recycling of aggregates. However, not everything can easily be recycled, and especially with batteries, due to the conglomeration of many rare elements within it, it's quite hard to separate them. Another one, just to meet increasing demand, could be new exploration. Now, it's been touted for quite a while, the idea of deep seabed mining. But obviously, this is issues in itself. I deliberately chosen the preface of a report by the International Union for Conservation of Nature, because obviously, deep seabed mining, no one knows what the damage may be to the seabed, and so therefore we can't just readily mine it because it will have all these issues surrounding it. And finally, there could be new technologies such as using pyrite in batteries, or another research project I undertook where I looked at the impact of clays in flotation, froth flotation. So if we can try and improve mineral processing techniques, we can try and mine lower grade ores and be more efficient. So we can get the same amount but for mining less, or we don't have to go to new deposits. We can mine lower grade deposits that we've already previously mined to try and reduce the damage. So concluding remarks. So demand will increase for all metals and minerals due to the green energy transition. A wicked problem is set up where there's no easy solution, as issues regarding mining are exacerbated and new ones are created as shown. And as I say here, there's no definitive solution and a combination of approaches required, and this will vary by mineral and by metal. So here was the references for what I showed you in my presentation, and I hope you enjoyed it, and I look forward to your questions. Thank you.